Now class, we go to the example 3. We need to find the critical points of y equal to 2x to the power of cube minus 3x to the power of 2 minus 36x plus 14, and then we have to state their nature. Remember, our first step here, we need to find y prime. In this case, it is easy to differentiate this function. So we have here 6x to the power of 2 minus 6x minus 36. And then we have to make this equation, which that is our y prime equal to 0. In this case, we have y prime equal to 6x squared minus 6x minus 36 equal to 0. And then you can see this is quadratic function. You can solve this one by using quadratic formula. But before that, we can actually simplify this function so that we have here all this divided by 6. We have x squared minus x minus 6 equal to 0. And how to find the value of x for this quadratic equation? We can use factorization, that is x times x. We got here x to the power of 2. And then we put here negative 3 times 2. You will got here negative 6. So negative 3x plus 2x, we got here negative x. Means that we got this one. That is, this factorization is correct. So that we will have here x minus 3 times x plus 2, which is equal to 0. Then we can solve this one, that is x equal to 3, and the other one is x equal to negative 2. Then we can evaluate number 2. We can find here the value of y for each x. In this case, when x equal to 3, okay, so x equal to 3, so our y equal to 2 times 3 cube minus 3 times 3 square minus 36 times 3 plus 14. Finding y here means that you have to refer back to the original question. Please don't confuse. It is not here y prime. So in this case, when we solve, we'll got the answer equal to negative 67. And then when x equal to negative 2, to compute our y here means that 2 times 2 to the power of cube minus 3 times 2 to the power of 2 minus 36 times 2. Okay, sorry, this one is bracket plus 14. So when we solve this one, we'll got the answer 58. Means that we have two stationary points here, that is 3, negative 72, and also 2, 58. So based on previous, we have here two critical points. That is the first one, negative 258. At this critical point, we need to draw a table. This is x, f prime x, and then we need to check for the slope. This is the step to check the nature of the critical point. So now here we put here negative 2, that is this critical point value. And this part is negative 2 at negative side, negative 2 at positive side. When the value of our x equal to negative 2, understood our f prime x will be equal to 0. That is, we have the straight line for our slope. But when value here for this negative 2 at negative side, let's say I choose here negative 3. When I choose negative 3, I have f prime negative 3 will be equal to negative 3 minus 3 times negative 3 plus 2. This is negative, this one also negative, so you will get the answer which is greater than 0, means that your slope here is positive, so going up. And then for this part, when I choose, for example, the value here, negative 2 at positive side, I can choose negative 1. Let's say I choose negative 1 here, I will have negative 1 minus 3 times negative 1 plus 2. So this one you got negative, this one you got positive, means that it is less than 0, means that here the answer for the slope is negative. So the graph here will going down. What we can conclude here, we have this kind of shape. this is a turning point of -2, so we can conclude that we have minimum turning point. And then for our second critical point, that is 3, -67, we plot here or we draw here a table x, f prime x, and then we check for the slope. Here we have 3 on negative side, and then here 3 on positive side. When we check, for example, 3 on negative side, I can choose value 2. So f prime 2, when I substitute, it is equal to 2 minus 3 times 2 plus 2, which is here negative, this one positive, so we'll got the answer less than 0, means that here negative value, so the slope will going down. But for this 3, it is 0, so here the slope just straight line. For the 3 at positive side, let's say we choose value 4, so now we have 4 minus 3, 4 plus 2, you can see positive, so it is greater than 0, means that our f prime x is positive, so the slope will be going up. When we want to conclude here, we have this kind of shape. This is our turning point. So this turning point have maximum turning point. This class how we can check and how we can find and check our nature of the critical points. So now it comes to the end of the week 13 part 2 video. See you next in week 13 part 3 video. Thank you. Now we go to this example 4. We have here a question which is given that y equal to x plus 1 square over x minus 1. We need to find maximum and minimum points of this function. So now the first step what we need to do, class, is you have to differentiate a function. So for step number 1, we have here y equal to, for this part, I can expand it. So I have here x squared plus 2x plus 1 divided by x minus 1. How can I differentiate this function? I can use here quotient rule because involve division to function. That is, numerator is u and denominator is v. In this case, our y prime will be equal to vu prime minus uv prime divided by v squared. So first, we have here u equal to x squared plus 2x plus 1. So our u prime equal to 2x plus 2. And then v, we know that it is x minus 1. So our v prime equal to 1. When we substitute in this formula, we have here our y prime equal to v, that is x minus 1, u prime 2x plus 2 minus u x squared plus 2x plus 1, or actually it is this one, x plus 1 squared. So I have here x squared plus 2x plus 1 times v prime, which is 1, divided by our v to the power of 2. So x minus 1 to the power of 2. In this case, how can we compute the maximum and minimum turning point? We need to make this y prime equal to 0. So in this case, we can simplify this equation. We have here y equal to, when we multiply this, we have 2x squared, okay, this one times this one, x times 2, so plus 2x minus 2x minus 2. Here, this one minus x squared minus 2x minus 1 divided by x minus 1 to the power of 2. And then you can see here we have 2x minus 2x, we can cancel out. And then we got here for this one 2x squared minus x squared, means that our y prime equal to x squared, this part, okay, and then minus this 2x minus 2x, and then here negative 2 minus 1, so minus 3, which is divided by x minus 1 square. And how to solve this one? You can actually factorize this part. Okay, when we factorize this part, we will have here x times x, and here negative 3 times 1. So we'll have equal to x minus 3, x plus 1 divided by x minus 1 square. And then how can we solve this one? We need to make this y prime, step number 2, our y prime equal to 0. So we have here y prime, which is equal to x minus 3, x plus 1 divided by x minus 1 square. It is equal to 0. This one you can move to this side. So you just have equal to x minus 3, x plus 1 equal to 0. So we have here our x, the first solution is 3, and another one x equal to negative 1. And then for x equal to 3, we compute here y. For this y at x equal to 3 equal to 3 plus 1 square divided by 3 minus 1. We'll got here y equal to 8, which is this one is 8. 3 plus 1, 4 to the power of 2, 16 divided by 2. So we got 8. And for this part, our y equal to negative 1 plus 1 square minus negative 1 minus 1. So you'll get the answer 0. So we have here the turning point. Our turning point for the first one is 3, 8. And for the second one is negative 1, 0. So this is 2 stationary points for this example. Next, we need to use a table to check which one is maximum and minimum point. We know from previous solution we have here a stationary point. The stationary point is given by 3a and also negative 1, 0. For the first step, we check for the first turning point, that is our x here 3, negative side of 3, positive side of 3, and then it's f prime x, also slope. Here, when 3, we know it is 0, so the slope is given just by straight line. In this case, when we substitute with the value of less than 3, we'll got here negative, so the slope is going down. This one will got positive, so the slope is going up, means that you will have this shape. So we have here maximum point. Maximum point 4, 3, 8. And then for negative 1, 0, we have here x, f prime x, slope. And then in this case, we have negative 1 at negative side, negative 1 at positive side. So for this case, for this negative 1, we know it is 0. When you check for the value of x less than negative 1, you will got here positive. This one you will got negative, means that this one will going up. Straight line going down means that you have this kind of shape. So this is minimum turning. That is, our maximum point is 3, 8, and our minimum point is negative 1, 0. This is the final solution of this example. So class, thank you. This is the last part of week 13 part 2 video. See you in week 13 part 3.